Today in class we started the unit called the mole, and our little mascot is a really ugly looking creature, but the mole in chemistry is really a unit that we're going to be dealing with. So before we began with the unit, we did some vocabulary. So you might want to pause the video and write this vocabulary down. The word atom is when we're talking about a single element. So if we had zinc, zinc would be called an atom. The word ion is when it's part of a compound, such as magnesium chloride would have magnesium ions and chlorine ions in it. The word molecule, the one with C, is for covalent compounds, and those are two nonmetals. So if we have a nonmetal, then that's going to be a covalent compound, and we refer to that as a molecule. So water has hydrogen and oxygen, both nonmetals, so therefore this is called a water molecule. We're going to abbreviate molecule, and our problem is MC. And then our last one is formula unit. If it is an ionic compound, and that's between a metal and a nonmetal, and that's when we have to swap the oxidation numbers, where we're going to be switching those oxidation numbers, then this is called a formula unit. So we're going to abbreviate that FUN for formula unit. So this is vocabulary that we're going to be doing. So the first part of our notes, we're just going to go through and write the formula and decide if it's an atom, whether it's a formula unit or a molecule. Aluminum would be written Al, and that's just a single element, so this would be known as an atom of aluminum. This is magnesium bromide. This is a metal, and this is a nonmetal, so therefore this is going to be ionic. So this is going to be known as a formula unit. But we need to practice writing the formula. So magnesium's oxidation number is +2. Bromine or bromide is a -1. And we're going to switch those. So it's going to become Mg1Br2. We want to get ready and be able to write those formulas. Dinitrogen trioxide. This is a nonmetal. And so we're just going to write what it says. This is covalent. Covalent, the one with the C, is a molecule, also the word with the C. And so dinitrogen is N2. Trioxide would be O3. Calcium is a metal. And then this is a polyatomic ion. And if you missed class, I gave out another polyatomic ion sheet because it says ATE. That is NO3, and that has a -1 charge. Calcium has a +2 charge. So the formula is Ca1 parentheses NO3 close the parentheses 2. And this is a metal and a poly, so this is ionic. So therefore this is called a formula unit. So the metals and nonmetals are formula units. The two nonmetals are called molecules. And we'll be using atoms, formula units, molecules in our problems. So I wanted to make sure you understood what those are. So I keep hitting that wrong button. We move forward. The mole is a special unit we use in chemistry to measure the amount of substance. 1 mole is going to be 6.02 times 10 to the 23rd, things that you can count, such as atoms, molecules, formula units. It's kind of like the word dozen always means 12. A mole always means you have that many of those things. This is known as Avogadro's constant, the 6.02 times 10 to the 23rd. Alright, so it says if you have 3.65 moles of silver, how many silvers would you have? First we're going to answer some questions. Is it ionic, covalent, or neither? Well, silver is not a compound, so therefore it is not ionic or covalent because it's not a compound. So it is neither. And it would be considered an atom because silver is just an element on the periodic table. And our formula for it would be Ag, because we want to practice writing formulas and knowing our symbols. So to start the converting process, which is what we're going to be doing, is converting. You're going to find your number, and it's 3.65, and then moles. And then the abbreviation for mole is MOL. And I'm sorry that you can put the E and you can put the S, but that is the abbreviation. So we have the number and we have the unit. The unit is always right behind the number. And then you're going to write the chemical symbol, and the chemical symbol is AG. So let's recap. Number, unit, symbol. Number, unit, symbol. And we're going to put that over 1. Then we're going to draw a dimension analysis table. Then our unit and our symbol, not the number doesn't move. The unit and the symbol is going to come down. Unit, symbol. And then what we're looking for is going to go in the top right corner. And we're looking for silver, and this silver is called an atom. So we're looking for atoms of silver. We're trying to figure out how many silver atoms this would be. Mole went down, atoms went to the top because that's what I'm looking for. We're using the word atom because silver is an atom. If it were molecule, we would be looking for molecules. If it was formula unit, we'd be looking for formula unit. Alright, so for a rule, we're always going to put 1 with the word mole. So 1 is always going to be associated with the mole. And for now, we're going to use Avogadro's constant. It's always going to equal 6.02 times 10 to the 23rd of things we can count. And atoms we can count. So here's mole. It gets a 1. And then we're going to put Avogadro's constant at the top. These will cancel, and you can see we have atoms of silver, and that's what we're looking for. Because we always multiply the things on the top and multiply the things on the bottom, and then take your top divided by bottom, 1 and 1 is just 1. So essentially we're just going to be multiplying those numbers together. And then we're just going to round to 3 numbers. We're going to get 2.20 times 10 to the 24th. And this is how many atoms of silver there are. So there's my answer there. Alright, so let's look at the next one. You have 0.943 moles of aluminum chloride. This is a compound, so it's not going to be an atom. Not going to be an atom because it's more than one. It's got a metal and a non-metal, so therefore it is ionic. And because it's ionic, it is a formula unit. And we have to take the oxidation number. This is a positive 3. This is a -1. And we have to rewrite our formula. So there's our formula for aluminum chloride. So then we have 0.943 moles of aluminum chloride. We're going to put that over 1. So this was my number, my unit, and there's my chemical. So number, unit, chemical, always over 1. Nothing should be down here with the 1, just a 1 all by itself. And then we're going to take the unit and the chemical, the label, and it will always move here. So it looks like that. So that is there. And then what we're looking for is going to go on top. Well, it says convert the moles, which is what we're doing, to either atoms, molecules, or formula units. And we already said it wasn't an atom and it's not a molecule. So we're looking for the formula units, and we're also going to put the chemical formula there. So notice your formula is here, here, and there. And our unit, here was moles, and now it's formula unit. So those are going to cancel. Anytime you have the word mole to the left, we're going to put 1. And we're going to put 6.02 times 10 to the 23rd with our other stuff, in this case formula units. Again, we're going to multiply. When we multiply, we get 5.68 times 10 to the 23rd. And this is our formula units of aluminum chloride. Again, if you need to pause this video and replay, you're always able to do that. Alright, on we go. Now we've got 7.74 times 10 to the 26 molecules. So this is our number, and there's our unit. So it's kind of giving itself away that it's a molecule. Because it's a molecule, it is covalent. So we're going to write what it says. Dichlorine is Cl2. Hept is 7, so we'll write O7. Cl2O7. We don't switch them on covalence. We just write what it says. So we're going to start with our number. And then our unit is molecule. Our abbreviation is MC. And then Cl2O7 is our label. We're going to put it over 1. This unit and the label is coming down. And what I'm looking for is going to go in the top right corner. And it says convert it to moles. So I'm going to put mole here, Cl2O7. Now, wherever mole is, it gets a 1. So there's mole. And then 1 mole equals 6.02 times 10 to the 23rd. Again, when you put this in the calculator, put parentheses because the little calculators will give you errors. Then essentially you're just going to divide. You're going to take this big number and divide by this big number. In your calculator, if you have it in scientific and rounding to 3 numbers, it would come out to be 1.29 times 10 to the 3rd. And then our unit would be moles of Cl2O7. Or if you're not in scientific, your calculator is going to give you 1285.7. We could round that to make it have 3 numbers to 1290 mole Cl2O7. I usually do not count off for sig digs in the regular class. So if you had put 1285.7, I'd be quite happy. So then we would have our unit and our label, because notice these are going to cancel out. So we're going to divide that number by that number, because one's on top and one is on bottom. All right. So now we're going to talk about what molar mass. Molar mass is always measured in grams, and it's the mass of 1 mole of our substance. So if you want to write that in your notes, it is on your note page. You can pause the video. But it is the mass measured in grams of 1 mole of our substance. Because nothing is going to weigh Avogadro's constant, because nothing weighs 6.02 times 10 to the 23rd grams. That's just too big of a number. So when we talk about molar mass, it's actually going to be a mass from the periodic table. So we're going to figure out how to do molar mass, and then we're going to work with it. All right, first we would want to write our formula. This is a nonmetal, so we just write what it says. It says sulfur, so we write S. Dioxide means O2. So there's my formula. So to find the molar mass, you list your elements. We have sulfur, we have oxygen, we count. We have 1 sulfur, we have 2 oxygens, and then we go to the periodic table and we use the atomic mass number, and that's that decimal number. And so we're going to look, and we're going to round to a tenth spot. If we look at sodium, it is 32.06, and I think there's even another 6 after it. I want a tenth spot. This is my tenth spot. So we want to know, is that 0 going to round up or not? And it's because it's a 6. We're going to round this to 32.1. So 1 times 32.1 is 32.1. We are multiplying. And then oxygen is 15.999. And so anytime it's 0.99 or 0.95 or more, basically think money, 95 cents, you can round to a whole number. So we're going to round this to 16.0. And 2 times 16 is 32.0. And all I'm going to do is add these 2 numbers together. So notice I counted, I multiplied by the mass of the periodic table, and now I'm just going to add. That's a 64.1. And 1 mole of this equals this many grams. That is the molar mass. 1 mole equals 64.1 grams. Another way we could write that is 64.1 grams per every mole. So this is another way to write it. So you can write it this way or this way. We're going to be using it this way in a moment. All right, our next one, the molar mass of calcium fluoride. Well, calcium fluoride is a formula unit because it's ionic. It's got a positive 2, and this is a negative 1. So it's CaF2. And so to find the molar mass, we go to the periodic table. Calcium is 1, fluorine is 2. And if we look at calcium, it rounds to 40.1. So 1 times 40.1 is 40.1. And fluorine actually rounds to 19.0. 2 times 19 is 38.0. And now we're simply going to add those together. We get 78.1. And so 1 mole equals 78.1 grams. Or you can say 78.1 grams for every mole. If they ask for the molar mass, you can write it either way. Again, we're going to be using this way in just a moment. All right. Next, if we said we had a dozen elephants, if you have a dozen, 1 dozen elephants, that means you have 12 elephants. I'm just going to put Ella. Okay? So, well, let me finish it out. But if I said, how much do a dozen elephants weigh, you wouldn't say a dozen elephants weighs 12 grams, because dozen doesn't mean a weight. A dozen means how many, things that you can count. So this is not a true statement. Because you wouldn't use dozen with 12, we don't use the word with Avogadro's constant when we're referring to mass. So this is a rule that we would write on our sheet. Never use 6.02 times 10 to the 23rd next to the word gram. You're going to use the molar mass instead. And we just learned how to do molar mass. So we've got 2 problems or 3 problems to work with this. Okay. First one, if you have 56.3 grams of potassium, how many moles would you have? Well, first we would write our formula, and it's an atom, so it's just K. So then we would write 56.3 grams of potassium. We would put it over 1. Coming down will be grams of potassium, and it says how many moles, so we're looking for moles of potassium. So grams went down, mole to the top. Anytime you have mole, to the left of the mole will go 1. Well, I'm not allowed to use Avogadro's constant here, so I am not going to use 6.02 times 10 to the 23rd. So instead, you're going to use the molar mass. Well, this is just an atom, so I just can go to the periodic table and write the molar mass for potassium. And potassium rounds to 39.1 because it's 39.09. So this will round to 39.1. And this will cancel. And I'll just take 56.3 divided by 39.1, and you will find that that equals 1.44 moles of potassium. So they have over a mole of potassium. All right. Our next one, how many grams would you have if you have 0.32 moles of zinc phosphide? Well, we want to write the formula correct first. This is a metal and a nonmetal, so this is a positive 2. Phosphide is a negative 3. So our correct formula is Zn3P2. So we'll start with our 0.320 mole of Zn3P2. And we're going to put it over 1. And there's my formula. It is moles right behind that number. That's why I'm starting with moles. We'll bring mole down. And we are looking for grams. So grams of Zn3P2. So there's the word mole. So the word mole gets a 1. And this is grams, so we are not allowed to use Avogadro's constant. So we'll come down, and we're going to do molar mass. There are 3 of these. There are 2 of those. And we'll go to the periodic table. Zinc is 65.4, and we're going to multiply, and we'll get 196.2. And then phosphorus is 31.0. We're going to multiply, so you get 82. Whoops, I wrote that wrong answer there, so sorry. I looked down. And so you get 62. And so we're going to add these numbers together. You get 258.2. And this is how many grams are in 1 mole. Grams in 1 mole. So this is going to go right there. So 258.2. And so this will cancel, and we're going to end up multiplying those numbers together. If we multiply those numbers together, zero point 0.3 times 258.2, you will get an answer of 82.6 grams ZN3P2. And there's my answer. So you can see I started to write that a second ago. All right, last example. How many moles are in 155 grams of sodium oxide? Sodium is a positive 1, oxygen is a minus 2, so you get Na2O. We have 155 grams of Na2O. We put it over 1. Coming down is going to be grams of Na2O. We're looking for moles of Na2O. The word mole always gets a 1. We're not using Avogadro's constant because it's grams. So we're going to go sodium's 2, oxygen's 1, and then we'll look on the periodic table, and sodium rounds to 23.0, and we multiply, we'll get 46, and then oxygen is 16.0, and we'll put 16, and we're going to add these together, and we get 62, and that's going to go down here always with our gram. It is 0.0, 0.0. You don't have to write the point zeros. And then I'm going to take 155 divided by 62, and you will find the answer is 2.50. We're putting the 0 because this has 3 numbers. Mole of sodium oxide. And that's it. That's part 1. And so we will go on to part 2 for our next video. But here are the correct answers that we are looking at. So for your homework, I have uploaded your homework as well. So here are the correct answers for that. Hopefully this video has helped you.